Hi everyone, my name's Matt, and while this might look like a normal old Wii on the outside, on the inside is actually a pretty powerful 8-core computer capable of playing a bunch of PC games along with emulating a ton of consoles. And this is more than just some parts thrown into a Wii case. I made sure to add some unique features like having the original power button turn on the system, and even made the GameCube ports fully functional so you can plug in and use up to 4 GameCube controllers at a time. It's far from perfect and it's not very practical, but I'm pretty darn happy with the end results and I'm very excited to share the entire process with you along with how it performs. But before we get any further, I want to take a minute to talk about the sponsor of today's video, iFixit, and their new FixHub Smart Soldering Iron. I've been using iFixit's tools and teardown guides for years now, so when I heard they're going to be releasing a soldering iron, I got super excited. The FixHub Smart Iron is a 100-watt USB-C powered soldering iron featuring a magnetic, heat-resistant cap and easily changeable tips. While the Smart Iron works great on its own, it's best when paired with iFixit's FixHub Power Station. This power station has a 55 watt-hour battery built in, giving you 8+ hours of wire-free soldering on a single charge. Its easy-to-use interface and dual USB ports allow you to connect and operate up to 2 soldering irons at once, with an auto cooldown feature, drop detection, and the ability to heat up incredibly fast. The FixHub portable soldering station is a great option for soldering pros and newbies alike. Also, because iFixit puts a big emphasis on repairability, by removing a few screws on the power station, you're easily able to replace the battery and repair other parts of the device in the future. To pre-order and learn more about the iFixit FixHub family of soldering products, make sure to head to the link in the description. Thanks again to iFixit for sponsoring this video, and let's get back to your regularly scheduled content. So without further ado, it's now time to tell you the story of how I turned this old Wii into a modern gaming beast. So I actually purchased this Wii broken on eBay about a year ago with the intention of doing this project, but I'm just now getting around to it. I think I paid $10 or $15 for it, and from what I remember, I think the problem with this Wii was just a broken disk drive. Getting it out of the packaging, we can see it just came with the Wii itself and a power adapter. Condition on this guy was pretty good. It was a little dirty, but didn't have any major damage or big scratches. I decided to test it out quick to see if it still powered on, and to my surprise it did power right up. For some reason I thought you could navigate the Wii OS with a GameCube controller, as I don't own a Wiimote, but that doesn't seem to be the case. What was even more surprising is that when it automatically loaded into the OS, I found this is actually a modded Wii with stuff like the Homebrew and Pirate channel. This was awesome to see, and while I won't be using the internals in this project, I will be saving them for a possible future project that I'll talk about in a minute. So the first order of business was to tear down the Wii and remove all the parts inside to make way for the new PC hardware. This was an adventure in and of itself. Nintendo, in their infinite wisdom, decided to use 11 different types of screws, with some being Phillips head and others being tri-wing. This took around 25 minutes to fully take apart, and I made sure to keep track of each screw and where it went using this magnetic parts board in case I need to reuse some in the final build. Eventually, I did get everything removed, including the motherboard and bottom shielding. I think what I'd like to do in the future is use the internals minus the disk drive in some sort of custom 3D printed case and have my own custom slim Wii. I would try and use this for a Wii portable, but from my understanding this board isn't a good candidate for that. So with all the internals out, I was left with the Wii shell itself, which would act as the canvas for this build. Now, the Wii, as you may know, is pretty darn small, so small in fact, even something like an ITX motherboard wouldn't even fit. Now, an STX motherboard like what I used in the GameCube build might have fit, but cooling would have been a huge concern. So I decided to turn to an area of computer hardware that's been exploding in the last couple of years, which is mini PCs. I've got a couple of these on hand, and the one that seemed like it would fit the build the best is this Mini Forums one featuring an 8-core Ryzen 7000 series APU capable of playing and emulating a ton of games. I'll go into specs more later in the video because for now I was just concerned if whether it would fit or not. Footprint wise it was definitely small enough, and from what I could tell was a similar height as the Wii itself, so the internals would probably have enough clearance. So I opened up the mini PC, and as you can see, other than the Wi-Fi antennas, the entire computer is confined to just this little board here. Placing it in the shell and putting the top on, it looked like it was going to be tight, but it would fit. This was great to see, and before I started modifying the shell at all, I wanted to think about everything that I wanted in the build and where I wanted to put them. First is, of course, the mini PC motherboard with the I/O facing the back. I also wanted to have a GameCube controller adapter, a power switch of some sort, and all the wiring required to hook everything together. This seemed like a lot of stuff to try and fit in such a small enclosure, but I knew if I took things one part at a time and thought everything through, I'd be able to make it work. So I decided to start with hauling out the shell a bit to make sure there was room to mount everything. I made note of the few standoffs I did want to keep on the bottom, and I also made a general drawing of where I wanted to cut out the back of the top panel for the I/O. I started by removing a bunch of standoffs with my rotary tool and a plastic cutting wheel. I probably should have been more thoughtful about which standoffs to keep, which I'll explain why later, but I removed all except a few of them. I then cut off these pieces right here and moved on to the top panel. When cutting this, I tried to undersize the hole a bit, as you can always remove more material, but you can't add more back. Once those cuts were all made, I used a variety of tools to grind down and file away the rough edges. With that done, I was left with a rough shell to attach everything to. I wanted to start by figuring out how I was going to mount the motherboard. In past projects, I've usually created or modified a DIY frame to fit all the parts, but this time I wanted to take a different approach. In this build, I wanted to try to design and 3D print custom mounts for most of the parts, but there's one small problem. I have very little experience 3D modeling, so I downloaded Fusion 360, watched about 30 minutes of tutorials, and dove right in. I started by measuring and modeling a very rough but pretty accurate model of the motherboard itself. Then I was able to build a motherboard tray around it. With that done, I exported the model, sliced it, and went ahead and printed it. I printed it in white ABS on my new Bamboo Labs X1C, which Bamboo Labs did very kindly provide to use in some videos, and while I won't be talking about it a ton in this video, I will say it is incredible and does 100% live up to the hype surrounding it. So with that printed, I got the motherboard, set it on, and realized that I didn't account for the fact the I/O ports stick out from the PCB, so I definitely needed to make some changes. I adjusted the I/O cover placement, added an actual fan grill, and printed it out. This time the board did actually fit correctly, and I was able to attach it with 4 regular motherboard screws going directly into the plastic. The ports were definitely still off by a bit, but this was a good start. Putting it into the shell and putting the top on, it looked like I also needed to shave a few millimeters off the height, which was totally doable. After changing things a bit, I ended up with this tray here, which fit height-wise, and that I was able to use to figure out how much more I needed to adjust the opening. So I just kept grinding away material until I got a decent fit. The opening definitely isn't perfect, but putting the motherboard tray in the shell and seeing it sit flush with the back was very encouraging and meant I was making solid progress on this build. I wasn't 100% sure how I would adhere the motherboard tray to the shell at this point, but I decided to let future Matt figure that out. The next major component I wanted to fit in was the GameCube adapter. Luckily, this one has almost perfect spacing for the holes on the Wii, but as you can see, in its current state is way too big, taking up almost as much room as the mini PC itself. Thankfully, opening it up, I found the internals of the adapter were way smaller than the shell implied. Pulling it out, it did fit nicely into the holes, but still was occupying space the motherboard needed. The part that was hitting is the mode switch that allows you to switch between PC and Wii U modes. Because this will always just need to be in one mode, it means I could pull off the switch and the wiring, which I probably should have desoldered, but I was being lazy. Then I could solder on a little piece of wire to bridge the 2 contact points, which is all a switch does. Now note, these were actually the wrong pins, but I didn't figure that out until later. But with the switch removed, the GameCube port's PCB fit in with very little room to spare. So then came the question of how I was going to mount and secure the ports themselves. So I started by modeling some basic geometry and doing a partial print to find if my tolerances were okay. I was happy to see the 2 pieces slid on nicely without any play in them, so then I designed a type of clamp that slipped over the controller ports and secured together with regular motherboard screws. This again fit in nicely to the Wii shell, but just like the motherboard tray, I needed to figure out how to mount it to the shell itself. So at this point, I had a big decision to make. I originally was going to mount these pieces with glue or epoxy, but if these ever broke or need to be modified further, it would be a huge pain to remove them. So I decided to use nuts and bolts to attach them to the shell. For the motherboard tray, this did require one final adjustment to the design. which added 4 screw holes, a more uniform exhaust grill, and holes for Wi-Fi antennas to mount to. To know where to drill into the shell itself, I first put in the motherboard tray and lined it up exactly where I wanted it. I attached some painter's tape to the I/O area and a few inside too, before lifting the top shell away. Then I added a bunch more tape to make sure the tray stayed exactly where I wanted it, then removed the motherboard, marked the holes, then removed the tray itself. I started by drilling smaller holes to make sure they're centered, then drilled out the final hole size. I then slowly went back and forth between countersinking and testing a bolt until it sat flush with the bottom, and made sure to do this with all 4 holes. Then I could insert the bolts, tighten them down with their corresponding nuts, and install the motherboard itself. Putting the top of the shell on, I was happy to see the I/O was sitting flush with the back of the Wii. For the controller ports, I designed a version of the mount with holes on the bottom for 3M bolts to screw directly into. I did a partial print of this, which I taped in place and used as a template for hole placement. I drilled the center out, attached it with a bolt, then drilled the other 2 holes and countersunk each of them. I then could attach the bottom of the mount with 3 screws. I next inserted the controller ports and secured them with the top of the mount and some screws. Testing with the shell on, the ports weren't perfectly placed, but they were good enough for now, and because the mount isn't glued in place, I can always design a new mount that would slightly adjust the port placement and still attach with the same 3 mounting holes. With that done, it was time to move on to the part I was dreading the most, which is the power button. Unlike a lot of other consoles, the power button for the Wii is actually directly integrated into the mainboard's PCB itself. Now honestly, the easiest way to implement both the controller ports and power button would have been to cut the PCB like this, mount that portion to the shell using the original standoffs, and then solder directly to those ports, buttons, and LEDs. With that being said, I do want to reuse this Wii motherboard, so that wasn't an option. Which meant I now had the fun task of trying to get a tiny switch to sit in a very precise location in 3D space. I started with a few small basic mounts that ended up breaking because they were too small for the switch. Once I got the tolerance right, the switch was able to securely slide in, and I mounted it to the case using one of the original standoffs. I created a bigger version of this which kinda just flopped around when trying to press the button. Making a version that went all the way to the bottom of the shell prevented the flop, but still was being pushed around instead of actuating, so I changed it to have a bolt attaching it for a more secure fit. Putting the top shell on, I was happy to feel and hear the new switch actuating, which you won't be able to really see, but just listen. With that done, I was happy to see the mounts for all the components were done. I just need to figure out how to wire them all together. The mini PC's motherboard has the power button and LED directly mounted to the board, meaning I'd have to run wires to it from the front of the Wii case. I soldered some wires to the power button contacts to make testing them easier, and found these 2 contacts would turn the PC on, and these 2 could be used for the front LED, which on the Wii was green. So I soldered 4 short female jumper wires to these 3 contacts, 2 of which were on the same pin for ground. Then I could solder 2 wires to the power switch and heat shrink them, and then do the same for this green LED. Yes, my solder joints are ugly, but I'm still pretty inexperienced at soldering, and at the end of the day, they work fine. Plugging these in, I found the power button was working fine, but even when the PC was off, the LED was still on, which I wasn't sure why, but I decided to figure out later. Moving on to the GameCube controller adapter, I knew this cable was way too long, so I needed to shorten it, so I cut it off here, cut the USB cables shorter, then I stripped the ends of the wires on both the USB cables and the adapter itself. Then it was just a matter of resoldering all these connections and covering them in heat shrink and electrical tape. And boom, I then had a much shorter USB GameCube controller adapter. To connect these, I decided to use a short USB-C to USB-A hub. I also thought I could just attach the LED via USB, and hopefully it wouldn't turn on unless the PC was on, so I used a sacrificial USB cable, added a 150 ohm resistor to bring the voltage down to what the LED needs, and electrical taped it to create my USB LED adapter. Unfortunately, the USB hub also still receives power while the PC is off, meaning this also wouldn't work. I'm not sure how to address this at this point. I could probably add an Arduino and figure out a way to have it only turn the LED on when the system's on, but I didn't end up having enough time to figure it out. With that, I had all the parts ready to be assembled into the case, and while I did test these individually as the project went on, I decided to plug everything in outside of the case and was very happy to see everything working, including the controller ports after changing the pins that were jumped. So it's time to put it all together and get to gaming. I started by installing the motherboard tray into the shell, then got the mini PC board ready by installing the Wi-Fi antennas, which normally are attached to the case of the mini PC, but I'm using ones you find in a desktop PC. Then I installed the antennas into the back I/O and screwed down the board itself. Next, I put into place and screwed down the bottom parts of the controller port mount, then installed the port adapter and secured it with the top piece and some screws. Next, I popped the power button into the mount and secured the mount with 2 screws and with 1 bolt. Then I installed the front panel and just hot glued the LED into place, as I still needed to find a better front panel LED solution in the future. Finally, I plugged everything in, popped on the top panel, screwed it down, attached the controller port panel and the 2 covers, and with that, for now, the build is done. So with it all together, it's time to quickly talk about the specs and see how it performs along with thermals. So the mini PC used in this build was the Minis Forum UM773 Lite. This features an 8-core AMD Ryzen 7 7735HS CPU with integrated AMD Radeon 680M graphics. This system retails for about $400 and includes 16GB of upgradable DDR5 memory along with a 512GB NVMe SSD, which I actually switched out for a 1TB one. CPU performance with this system is amazing, but with integrated graphics we'll see how well it performs in gaming. Starting things off with emulation, I think this would be a great living room PC to play a bunch of old consoles on, and yes, you can ironically emulate GameCube and Wii games on this PC. For the GameCube, I tested Rainbow Six 3, which seemed to run just fine, even if I had a hard time figuring out the button layout. For the Wii, I tested Mario Galaxy by just trying out the start of the game, and this also seemed to run perfectly fine. Something to note is I test these games at native resolution, but what's cool about emulation is you can always crank up the resolution scale to make old games look way sharper if you have the PC horsepower to do so. Next, I tested Wii U emulation by trying out Breath of the Wild at native res with the community graphical enhancements enabled. This ran very smoothly in the dungeons with a locked 30, but in the overworld the FPS did drop into the 20s at times. This is not unplayable in my opinion, but would probably not be enjoyable for everyone. Next, I tested out PS3 emulation by running a Ratchet & Clank game. This ran very smoothly and I had no issues getting through the first mission. Also, this game looks surprisingly good for being a PS3 title and running at native res. Finally, I decided to see if the system could handle Switch emulation. First, I tested Super Mario Odyssey, which did stutter a little bit, but overall performance was very solid in my opinion. I also decided to test Pokemon Legends Arceus, which did end up also performing very well with a few stutters here and there. Something to also keep in mind is with emulation you'll often run into weird bugs or graphical glitches like what you can see here. Overall, emulation performance on this little Wii sleeper PC is very solid in my opinion. I don't test emulation performance that often, but if there's a system or specific title you'd like to see tested in the future, let me know in the comments below. Next, let's test some PC games because this is, after all, a PC. I started things off light with the esports title Valorant, which I tested at 1080p low settings and by hopping into a deathmatch. Doing this resulted in a solid 221 FPS average with 1% lows of 134. This is pretty good performance in my opinion. Next up is another esports title, Rainbow Six, which I tested using the built-in benchmark at 1080p medium settings. Doing this resulted in a decent 121 FPS average with 1% lows of 93. This isn't amazing performance or anything, but should be enough for casual play. The final esports title tested was Fortnite, which was run at 1080p pro settings with performance mode enabled. The FPS was solid at 98, but as usual the 1% lows were far from good at 16. Moving on to an older AAA title, I tested Borderlands 3 at 1080p low settings using the built-in benchmark. Doing this resulted in a 54 FPS average with 1% lows of 37, which is definitely playable and shows that older AAA titles run just fine on this machine. Next, I tested Cyberpunk 2077 at 1080p low, again using the built-in benchmark. Doing this resulted in a not so great 43 FPS average with 1% lows of 22. This is on the edge of playable and not what I would personally deem as an enjoyable amount of performance. Finally, I tested Elden Ring at 1080p low, and by doing the Melania fight, during this fight the FPS fluctuated between the low 40s to low 50s, which was honestly playable and didn't make me feel like I was at a huge disadvantage. With that being said, Elden Ring is definitely a game you want stable performance in. Overall, performance on this Wii Sleeper PC is pretty good. It's great for emulation and easier to run PC games, but definitely isn't 100% suited for modern AAA titles. In terms of temps, this PC stayed mostly in the low to mid 80s, with it sometimes spiking to the high 80s. This isn't in the realm of thermal throttling from what I understand, but it's about an average of 15 degrees higher than when the board's just running in open air. The back vents offer good ventilation for that part of the cooler, but the other portion of the cooler has to use this much smaller part on the side of the Wii right here. So now let's talk about the project as a whole. What still needs to be done, what's done well, and what could have been done better. The main things I'd like to change / fix are 1. The front panel LED. I'd like to find a solution that only turns on when the PC's on and make an actual mount for it. 2. The gap around the back I/O isn't great, and I may be able to fix that with either filler or some more grinding and an adjustment to the back panel height. And while the GameCube ports work fine, I think they could be adjusted a little bit more. Finally, I have the exposed bolt heads on the bottom of the Wii, which I can either paint white or cover with little vinyl stickers, which is what the Wii originally used to cover a lot of its screws. With that being said, I personally kind of like how it looks with the exposed silver screws. In terms of what was done well, I think the mounts for the parts turned out pretty good for me having such little experience 3D modeling, and I'm super happy I was able to fit a functional GameCube adapter and was able to make the original power button turn on the PC. With all that being said, I'm interested to hear what you guys think of this build. Make sure to let me know in the comments below, along with what system you think I should do my next sleeper PC in. So yeah guys, I think this wraps this video up. I hope you guys enjoyed it. If you did, make sure to give it a thumbs up and consider subscribing. And as always, this is Matt from Tech by Matt, signing out.